Hello class, we're still learning how to simplify radicals, but we're going to add to it how to find the discriminant. We're doing this in preparation for using the quadratic formula. So, how do I simplify radicals and find the discriminant is our essential question. Learning intention. I'm learning to simplify radicals and to find the discriminant. So, you've got two warm-up questions, solve these trinomials. In other words, find where those quadratics cross the x-axis. Pause the video and see if you know how. I hope you tried on your own. Now, on the first one, is it set equal to 0? No. If it's not set equal to 0, you cannot even begin. This is a minus 15 over here, so that means it will be n squared plus 8n. I've got to add the 15 to both sides, plus 15 is equal to 0. Now I'm ready to solve. So I've got 15 up here, I've got 8 down here, and both are positive. Everything is now positive. What are my factors of 15 that add up to 8? Well, that would be 3 times 5. So n plus 3 times n plus 5 is equal to 0. Now, we've been trying to do a shorthand form of this. So, to be equal to 0, I know n must be equal to. What is the opposite of 3? Negative 3. What's the opposite of 5? Negative 5. So when the graph will go down through negative 5 and come back up through negative 3. Remember, it's that parabola, that U shape. Okay, so the next one was solved equal to 0, so you can just jump right in. (24) goes up here, it's positive. Negative 11 goes down here. The only way I can get a positive when I'm multiplying and I know that one has to be negative is if both are negative. What are the factors of 24 that add up to 11? Well, 1 and 24 does not add up to 11. 2 and 12 do not add up to 11. 3 and 8 do add up to 11. So it's negative 3 and negative 8. And this time it'll be minus. So x is equal to, what is the opposite of negative 3? Positive 3. What's the opposite of negative 8? Positive 8. And we are done. So let's look at prime factorization and simplifying radicals. So you can do it different ways, but I always like to find all the prime factors if I don't know what the answer is. So if I'm looking at 12, 12 is even. I can divide it by 2 and I get 6. 6 is even. I can divide it by 2 and I get 3. 3 is prime, so I divide by 3, I get 1. When I get 1, I am done. Circle your pairs because these are square roots. 2 square root of 3, and that would be a positive or a negative. Positive is your primary, negative is your secondary. Okay, so pause the video. Can you do the square root of 50 on your own? Well, I do hope you tried. 50 is even. I can divide it by 2 and I get 25. 25 is not even. It will not divide by 3, but it will divide by 5. 25 divided by 5 is 5. 5 is prime. 5 and a 1, and when you get 1, you're done. I've got a pair of 5s. So this would be a positive or a negative 5 square root of 2. Okay, if you didn't try on that one, pause now and see if you can do the next one, the square root of 750. I hope you tried. So, first thing, is it even? Can I divide by 2? Yes. Whoops, that was me dropping my calculator. $750 divided by 2 gives me 375. Is 375 even? No. Is it divisible by 3? Yes. 3 plus 7 is 10. 10 plus 5 is 15. I can divide by 3 because 15 is divisible by 3. I get 125. Can I divide by 3 again? No. 1 plus 2 is 3. 3 plus 5 is 8, and 8 is not divisible. So now I'm going to have to look again. The next number would be 5, so I'll hit divide by 5. I get 25. 25 can be divided by 5 again. I get 5. Divided 5's prime. Divide by 5, I get 1. I am looking for 2 of a kind. So I've got 2 5s, and that's it. So this is equal to positive or negative 5 square root of 2 times 3 times 5. 2 times 3 times 5. Positive or negative 5 square root of 2 times 3 is 6 times 5 is 30. And I am done. Okay, on the next one, we've done the square root of 108, but what about the cubed root? Cubed root means we're looking for 3 of a kind. $108 is even. I'll divide by 2. I get 54. 54 is even. I'll divide by 2. I get 27. 27 is not even. I can divide by 3. I get 9. 9 is divisible by 3. I get 3. 3 is prime. I get 1. When I hit 1, I am done. For the cubed root, for the third root, you are looking for 3 of a kind. Remember, this one is not positive or negative. It is simply positive, because you can take the cubed root of a negative number. So this is 3 square root of 2 times 2. 3 square root of 4. And that is the cubed root, not the square root. Put the cubed root up there and we're in good shape. So hopefully this is starting to make more sense. You're starting to get the pattern down. If not, we'll give you more practice and we'll work with you to get that figured out. Okay, when we're looking at radicals, this 5 is not the fifth root because it's not in that little v. This is 5 times the square root of 48. But we don't know what the square root of 48 is. So let's do our prime factorization. 48 is even, so I can divide by 2. I get 24. 24 is even. I can divide by 2, and I get 12. 12 is even. I can divide by 2, and I get 6. 6 is even. I divide by 2. I get 3. 3 is prime. 1, and you're done. How many pairs do I have? I've got 1 pair of 2s. I've got another pair of 2s. I've got 3 left over. So this is equal to 5 times 2 times 2 square root of 3. 5 times 2 times 2 square root of 3. Okay, 5 times 2 is 10. 10 times 2 is 20. 20 square root of 3. If you notice, we did not put a plus or minus on this because they've got the 5 out here, which sets it as a positive. Okay, pause the video. Can you do the next one on your own? Well, I hope you tried. Okay, I'm looking at 32. 32 is even. I can divide by 2. 32 divided by 2 is 16. 16 is even. I can divide by 2. I get 8. 8 is even. I can divide by 2. I get 4. 4 is even. I can divide by 2. I get 2. 2 is prime, so I divide by 2 one last time. When you hit 1, you are done. Once again, we're pairing it up. I've got one pair of 2's. I've got another pair of 2's. Then I've got this one left over. But I also have 8 out front. So it's 8 times 2 times 2 square root of 2. 8 times 4 is 32 square root of 2, and we're done. Okay, we're looking at the quadratic formula. We're looking at the discriminant and the standard form of a quadratic. The standard form of a quadratic is ax squared plus bx plus c equals 0. It must be set equal to 0 to solve. Your discriminant is b squared minus 4ac. Look at where it's at. It is under the radical sign. So whatever the discriminant is, we will be taking the square root of it. So what does this discriminant have to be in order to have two solutions? Think of a square root. If you look, we're doing two different equations with it. First time we'd add, second time we would subtract. So if it's 0, would we have two solutions? No, we'd only have one. Could it be a negative number? Can we take the square root of a negative number? No. So if it is greater than 0, then we'll square root it and we'll take, first time we'll add, second time we'll subtract as we put it into the formula. If it to be one solution, we just talked about it, it's got to be equal to 0. Because we're adding and subtracting 0, which doesn't change that, the opposite of b. Finally, how can we have no solutions? Well, we cannot square root a negative number, so if it is less than 0, there's no way to take the square root because we don't know how. So we've got 4 of these we're going to find the discriminant for. Find A, B, and C. A is 6. B is -2. C is -3. Now let's put it into our formula. B squared minus 4AC. Okay, so what is B squared? -2 squared minus 4 times 6 times -3. Okay, what do we end up getting? This is 4 minus 6 times 4 times 6 is 24 times 3. We end up with 72. So this is minus a negative 72 because you're taking and multiplying by negative 3. So this would be 4 plus 72, which is 76. Is 76 greater than 0, equal to 0, or less than 0? It is greater than 0. There will be 2 solutions. Okay, let's look at the next one. What is A? What is B? What is C? A is 9. B is negative 3. And C is 2. Let's put it in our formula. B squared, negative 3 squared, minus 4 times 9 times 2. Negative 3 squared would be 9, minus 4 times 2 is 8, times 9 is 72. So 9 minus 72 is going to be negative 63. How many solutions? None, because we can't take the square root of a negative number yet. Okay, on the next one, what do you notice that we have to fix? If you said you notice that we've got to set it up equal to 0, you would be right. To set this one up equal to 0, I need to add 9b squared to both sides. Okay, now we can get started. What is A, B, and C? A is 9, B is negative 8, C is positive 8. So, here we go. Negative 8 quantity squared minus 4 times 9 times 8. This would be 64 minus, okay, 4 times 9 times 8 is 288. Okay, so 64 minus 288 gives me negative 224. How many solutions? Well, it is less than 0. We cannot take the square root of a negative number. No solutions. No real solutions. I need to correct that because there are imaginary solutions, but no real solutions. Okay, pause the video. Can you set the next one up on your own? Okay, let's look at it. Is it set equal to 0? No. Can I move the 6 over, or should I move everything else to the other side and make everything positive? Well, when you're using the quadratic formula, it really doesn't matter. So I'm going to add 6 to both sides. Negative 2x squared minus 8x minus 8 is equal to 0. Negative 14 plus 6 is negative 8. A is equal to negative 2. B is equal to negative 8. C is equal to negative 8 again. B squared is negative 8 squared minus 4 times negative 2 times negative 8. Okay, now, if I do not use parentheses here, it's going to give me a negative number. Parentheses, negative 8 squared minus 4 times negative 2 times negative 8, and I get 0. If it is equal to 0, how many solutions? Well, only one, because when you add or subtract 0 from a number, it doesn't change the number. Success criteria? I know I'm successful when I can find the discriminant of a quadratic and identify the number of solutions. So we simplified radicals. And then we found the discriminant. And the number of solutions.